Good day, students. Welcome to Mathgotserved.com, where we don't just solve, we teach. In this clip, we're going to be going over problems 16 to 20 of the January 2016 Geometry Common Core New York Regents exam. Our goal here is to go over some tips and tricks to help you be successful on your upcoming exams. Any questions can be placed in the comment section below this video, and we will be glad to assist you. All right, let's take a look at problem number 16. It says in the diagram of right triangle ABC shown below, AB is 14 and AC is 9. Question, what is the measure of angle A to the nearest degree? So one tip you want to keep in mind when you're using SOHCAHTOA, which is right triangle trigonometry problem solving process, is that SOHCAHTOA is always done with relative to an angle. Okay, so SOHCAHTOA basically relates an angle to the ratio of any two sides. So in this problem, we're looking for angle A. So our reference angle will be angle A. So what we're going to do is we're going to label this triangle relative to this angle. Okay, so you want to keep that in mind. Now, the angle that we are labeling our triangle with reference to, the side opposite that angle is known as your opposite. Okay, so this is my opposite, and the side opposite the 90-degree angle is the longest side because 90 degrees is the biggest angle in this triangle, so that is the hypotenuse, and then the other side is the adjacent. All right, so A, O, and H are what you have in SOHCAHTOA. S, C, and T are sine, cosine, and tangent. So let's go ahead and write down SOHCAHTOA real quick. So SOHCAHTOA. So what this basically tells us is that, as you might already know, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent. So which ratio can we use to solve this problem? What we're going to do is we're going to look at the two sides that we know and the angle that we do not know. Okay, so the angle is the unknown, so we need to know two sides in order to figure out the angle. We do not know the opposites, so we are just going to scrap that. This side right here, side CB, we don't know it, we don't need to find it, so we just scrap it. Okay, now we need to find angle A, so we know AC and AB, A and H. So which trig ratio, sine, cosine, and tangent has only A and H in SOHCAHTOA? You can clearly see that it is cosine K. Okay, so cosine of the angle A is equal to the adjacent over hypotenuse. Okay, so cosine of angle A, we don't know what angle A is, equals the adjacent, which is 9, divided by the hypotenuse, which is 14. Now, how do we undo cosine and isolate angle A, the measure that we're looking for? Don't divide by cosine, that's inaccurate. In order to undo cosine, you have to use its inverse, known as inverse cosine or the arc cosine. Okay, so what you do is you take the arc cosine or the inverse cosine of both sides of your equation. Okay, inverse cosine of the left side and the inverse cosine of the right side of your equation. Inverse cosine 9 over 14. Now, why did we take the inverse cosine again? Because that's what undoes cosine. All right, on the left side you have some cancellation action happening, and you have angle A is, now we need our calculator to assist us with computing the inverse of the inverse cosine of 9 over 14. Okay, so I want to make sure I'm in the right mode. I'm in degree mode, which is good. So you go second function cosine, calls up your inverse cosine function, 9 divided by 14. And our answer is 49.9948. 49.9948 to 4 decimal places. To the nearest degree, the measure of angle A is going to be 50 degrees. Okay, to the nearest degree. In this case, we're just rounding up because we have a 9 behind this 9. Answer is option number 3. All right, let's take a look at problem 17. It says, what are the coordinates of the center and the length of the radius of the circle whose equation is x squared plus 6x plus y squared minus 4y equals 23? So in this problem, we're going to have to express the equation of this circle. This is the general form. We're going to express it in center radius form, okay? One caution is that when you are determining the center and the radius, given the center radius form, do not forget to take the opposite of the numbers next to the x and y and to take the square root of the constant to find your radius, okay? That's a common mistake most students make. You want to look out for that on the upcoming exam. All right, so we have x squared plus 6x plus y squared minus 4y equals 23. So we want to express this in center radius form, okay? So to accomplish that, we have to complete the square. So we're going to deviate down the center. Now what you notice here is that the x's are together and the y's are together and the constant is on the right side. If you're given the equation of a conic and it's not in this format, you have to place it in this format first before completing the square. Well, why is that? Well, you want to keep the x's and the y's separate so you can complete the squares independently so that you can determine the correct coordinates for the center, okay? So what am I talking about? Check this out. I'm going to express the x component as an incomplete square. It's already incomplete, but check this out. I'm going to put a dash here to show you that we're missing a piece to make this a perfect square trinomial. And then on the y world, I'm going to express it in the same format too. Now, we have to add two numbers, one to the x, one to the y, to make a perfect square trinomial in both worlds. And I have to add the same number to the right side of the equation so that my problem remains unchanged. My equation has to balance, okay? If I add stuff to the left side and I do not add the same amount to the right, then it's no longer an equation, it's something totally different. Okay, so how are we going to complete the square? To complete the square, you have to remember that you always add b over 2 square to complete the square. Now, let's take a look at the x world. In the x world, this is my b right here. So b for the x world is 6. So I'm going to divide it by 2, which is 3, and I'm going to square that, which is 9. Now, inserting a 9 here makes my x world a perfect square trinomial, okay? Now, let's take a look at the y world. In the y world, my b for my y world is -4. Divide that by 2, again, -2. Squared. Remember, b over 2 squared completes the square. We get a 4. And I added 4 here. Okay? Now, notice what I did. I added two numbers to the left side of the equation. What must I do in order for the equation to remain unchanged? I have to add those numbers to the right side too. So I have to add a 9 and add a 4. Now, this equation is just the same as that, but just in a different form. Now let's complete our perfect square trinomials. That's pretty easy to do. Just take the square root of the first and the last term in your x world, and then you drop down the middle sign, okay? That leaves you with x plus 3 quantity squared. There goes your perfect square trinomial in factored form. The same procedure applies to the y world. You take the square root of the first and last term, and you bring down the middle sign. So for the y world, we are going to have y, in this case, is going to be -2 quantity square. 23 plus 9 plus 4, 23 plus 13 is 36. Okay, now let's find our center and radius. Center, remember what we talked about earlier? You want to take the opposite of these two numbers, okay? Don't just say 3 and -2, and then you fall into one of these traps here. So you have the opposite of +3 is -3. And the opposite of -2 is +2. Okay, so we can eliminate options 1 and 2. Now the second caution is the radius. Students often just select this number here as the radius, but that's the square of the radius. What you're going to do is you're going to take the square root of 36, and the radius is actually 6. Answer is option number 4 for number 17. Okay, let's take a look at number 18. It says the coordinates of the vertices of triangle RST are -2, -3 for R, 8, 2 for S, and 4, 5 for T. Which type of triangle is triangle RST? Now, let's go ahead and sketch this triangle since we're provided with the coordinates, and it will give us a general idea as to what kind of triangle it is. Then we can verify with the tools of geometry what it is with precision. Okay, so let's start by graphing. Vertex R, -2, -3, 1, 2, 1, 2, 3. Bam, there's where R is. And then let's label it. So R is -2, -3. -2, -3. Next coordinate, let's graph T. T is 4, 5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Bam, there goes T. This is just to give us a visual, okay? And lastly, S is 8, 2. 4, 5, 6, 7, 8, 1, 2, bam. There goes S, which is 8, 2. Okay, let's go ahead and draw a triangle RST, defined by these 3 coordinates. Bam. Okay, now take a look at this triangle. What do you think this triangle is? What type of triangle do you think it is? Doesn't angle T look like a 90-degree angle? It certainly does. Okay, so it looks like our answer is going to be option number 1, but we can't make assumptions. We have to know for sure that this angle is in fact right so that we can conclude that triangle RST is a right triangle. Okay, now something you want to recall in terms of determining the perpendicularity of 2 segments is that if 2 segments are perpendicular, then their slopes are opposite reciprocals of each other. Okay, so if RT is perpendicular to RS, the slope of RT must be the negative reciprocal of R of TS. Okay, so let's go ahead and find the slopes of these 2 segments and see if they're in fact perpendicular. If they are, then this is 90 degrees, and our answer will be option number 1. Okay, so remember your slope formula. M is y2 minus y1 over x2 minus x1. Let's find the slope of r. Wait a minute. Let's find the slope of RT first. Okay. So slope of RT. So RT. We're just gonna let's call this. This is y2 x1 x2 y2, and then this is x1 y1. Okay, so let me label it for you. So this is, we'll call this y2, y1, x2, sorry. And then this is x1, y1. Why am I labeling it? Well, I want to use the slope formula to find the slope, okay? Or if you want to do a quicker way, you can do it. You can do your rise over run. I think that'll be faster. So let's do that. So if we rise, we can count our rise. 1, 2, 3, 4, 5, 6, 7, 8. So we rise 8. And if you subtract the y's, you get 8 anyway. 5 minus -3 is 8. And then you run 1, 2, 3, 4, 5, 6. We run 6. Or if you do x2, 4 minus -2, you get positive 6. Okay, if we reduce this, the slope of segment RT is 4 over 3. Now let's find the slope of segment RS. If it is -3 over 4, the opposite reciprocal of this, then this is a right triangle. Okay, so we're going to do rise over run, but in this case we're falling and running. Okay, so our rise will be a negative rise, 1, 2, 3. How do you capture that? That's -3 since you're falling, okay? Over your run, 1, 2, 3, 4, -3 over 4. Are these two lines negative reciprocals of each other, these two slopes? They are. So guess what? RT is perpendicular to RS. So since RT is perpendicular to RS, that follows that triangle RST is a right triangle. Answer is option number 1. Our suspicion was correct, that this is in fact a right triangle right here. All right, let's take a look at problem number 19. It says, Molly wishes to make a lawn ornament in the form of a solid sphere. The clay being used to make the sphere weighs 0.75 pound per cubic inch. If the sphere's radius is 4 inches, what is the weight of the sphere to the nearest pound? There are two formulas we're going to be using for this problem. First of all, we're going to find the volume of the sphere, and then we're going to find the volume of the sphere using this, the weight of the sphere using this condition that a cubic inch weighs 0.75 pounds. Okay, so first formula is volume. The volume of a sphere is given by 4/3 pi r cubed. And then total weight formula, total weight is basically the unit weight per cubic inch, in this case, unit weight, multiplied by the volume. So you're scaling the volume using your unit weight, okay? So we're gonna start out by first computing the value of the volume of the sphere, and then we will apply the total weight factor to scale it up to the actual size, okay? So volume is 4/3 pi r cubed as indicated earlier. The volume is only dependent on the radius. So let's see here. The radius is 4 inches. Okay, we're gonna make sure that the units agree, so they do, so that's good. So volume is gonna be 4/3 pi times 4 to the third power. All right, if we multiply them across, we're gonna end up with 4 times 4 to the third, that's 4 to the fourth power, which is 256 pi divided by 3. Okay, just multiply the numerators and then imagine that there are ones here, multiply the denominators across. Okay, so let's find out the total weight. So total weight is simply going to be, the actual weight is going to be the unit weight, which is 0.75 multiplied by the volume. Okay, so 256 pi divided by 3. We are going to need our calculators to compute the value of this product. So 0.75 times 256 pi divided by 3. And your answer is 201. 201, well, it looks like I made a mistake in my entry. Let's do that again. Okay, I see what the mistake is. The unit weight is 0.075, so let's apply that there. So it's supposed to be 0.075 over here, 0.075, and then that's what we're going to enter into our calculators. Our answer should be 20. As you can see, we're just adjusting the decimal place. So let me call up my previous answer, previous entry, and I'm going to insert a 0 here. So let's insert a 0. Perfect, enter. Okay, that looks more like it. So total weight is 201.106, 20.106, 106. All right, but in this problem, we are asked to round to the nearest pound. So rounding this to the nearest pound is 20 cubic inches. because the number behind the 0 is less than 5. So you round down. Answer is option number 2 for question 19. Okay, let's take a look at number 20, the last in this review installment. It says the ratio of similarity of triangle BOY to triangle GRL is 1 to 2. If BO equals x plus 3 and GR equals 3x minus 1, then the length of segment GR is. So one thing you want to note concerning similarity of triangles is that if two sides have a ratio of similarity of A to B, then the corresponding sides will be in the ratio of A divided by B. So this fact will help us to set up our ratios and ultimately solve for what the length of our segment GR is. Okay? So to help us get a visual, I'm just going to create two random triangles. Try to make them as similar as possible. This is not perfect. Okay, so this is the smaller triangle, and then the other one should be like double the size because the ratio is 1 to 2. This is not drawn to scale by any means. Okay, so we have triangle BOY. You have to follow the order of the alphabets of the letters, okay? Or else you're going to ruin the problem. And then this is GRL. Okay, now BO, this segment right here, x plus 3, this corresponds with GR, as you can see, 3x minus 1. Since they're in the ratio of 1 to 2, these corresponding sides are going to be in the ratio of 1 over 2. So what I'm saying in essence is the ratio of these corresponding sides, BO over GR, is going to be equal to this ratio, 1 over 2. Okay? Now, what is the measure of BO? BO is an algebraic expression, x plus 3. How about GR? GR is another algebraic expression, 3x minus 1 equals 1 over 2. Now we have a rational equation. To solve this, we want to get rid of the denominators. It's kind of annoying, okay? So we can cross multiply here to get rid of these two denominators. Denominator on the left, you multiply to the numerator on the right. Denominator on the right, multiply to the numerator on the left. So if you cross multiply, you have 2 times x plus 3 equals 3x minus 1. The reason why I put the parenthesis here is I do not want you to forget distributing this 2 to both x and 3. Okay? So don't forget that 2x plus 6 equals 3x minus 1. Now we have an algebraic equation with variables on both sides. So what we want to do is collect all the x's on one side and have the numbers on the other side, okay? So let me put it here, 2x plus 6 equals 3x minus 1. So let's move the x's to the right, because if I move it to the left, I'll end up with negative, and that's an additional step. So let me subtract 2x from both sides. It doesn't really matter how you do it. So I will have, and then I can switch the equations around. Let me not do that so you don't get confused. So have a 6 here. 3x minus 2x is x minus 1. Okay, now we have all the variables on one side and combined. Now the numbers go to the left side, so you add 1 to both sides of your equation, and you have, switch it around, x, 6 plus 1, 7. Okay, so the measure of the value of x is 7. So is that our answer? Is our answer 7? If you notice, we have a 7 here as an option. Is that our answer? The answer is no. That this right here is a good trap. It's a great trap, to be specific. Now, notice the problem asks us to find the length of GR. We are not done yet. We are almost there. We just found the measure of x, which is a determiner of the value of GR. So we have one more step to go. GR is 3x minus 1. So you substitute your value of x into this expression, and that would tell you what GR is. 3 times 7, 21 minus 1, which is 20. Answer is option number 4. The key takeaway here is make sure you are answering the question. Don't stop halfway. and see a distractor and rejoice and pick it, you fall into a trap. Always make sure that you're answering the question, especially when you're given side lengths and variable expressions to represent those side lengths. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. Your positive feedback is very important to us. Don't forget to subscribe for updates to the remainder of this review series. Any questions, just include that in the comment section below and we'll be glad to support you. More clips can be found on mathgotserved.com. Thanks again for watching and have a wonderful day.